Hi, welcome all. Hello. Hmm. Hi, welcome all to the online classes. Today, I am Mukesh Bhardwaj is going to discuss the topic types of diode. On the last one, we had started with the types of diode in which we had discussed Zener diode, avalanche diode, photodiode. Now, we are going to start with light emitting diode. Okay. So, without wasting the time, I'm starting with light emitting diode as we all are aware about the concept of a diode. What do you mean by the diode and how the diode works in the forward bias region and in the reverse bias region? So, light emitting diode is a type of diode. And before starting to the light emitting diode, I would like to just focus on what do you mean by light. So, light is basically, before going into that how LED works, let us first take a brief look at light self. Light self. Since ancient times, man has obtained light from various sources like sun rays, candles, and lamps. In 1879, Thomas Edison uh, invented the incandescent light bulb. In the light bulb, an electric current is passed through a filament inside the bulb. When sufficient current is passed through the filament, it gets heated up and emits light. The light emitted by the filament is the result of electrical energy converted into heat energy, which in turn changes into light energy. Unlike the light bulb, uh, in which electrical energy first converts into heat energy, the electric energy can also be directly converted into light energy. In light emitting diodes, electrical energy flowing through it is directly converted into light energy. Light is a type of energy that can be released by an atom. Light is made up of many small particles called photons. Photons have energy and momentum but no mass. Atoms are the basic building blocks of matter. Every object in the universe is made up of atoms. Atoms are made up of small particles such as electrons, protons, and neutrons. Uh, Electrons are negatively charged, protons are positively charged, and neutrons have no charge. The attractive force between the proton and neutrons make them stick together to form nucleus. Neutrons have no charge, hence the overall charge of the nucleus is positive. What is light emitting diode? Light emitting diodes are most widely used semiconductor diodes. Among all the different types of semiconductor diodes available today, light emitting diodes emit either visible light or invisible infrared light when forward biased. The LEDs which emit invisible infrared light are used for remote controls. And light emitting diode is an optical semiconductor device that emits light when voltage is applied. In other words, LED or light emitting diode is an optical semiconductor device that converts electrical energy into light energy. These are some pictorial beautiful representation of LEDs. As you observe these LEDs, one length of the lag is bigger and one is smaller. Uh, to just identify uh, in forward biasing condition which lag is needed to connect with positive terminal of the battery and which is to connect with negative terminal of the battery. So therefore, the difference between the lags are to be kept in the LEDs, in the manufacturing of LEDs. When light emitting diode is forward biased, the free electrons in the conduction band recombines with the holes in the valence band and releases energy in the form of light. So the internal physics is nothing when free electrons, when in conduction band recombines with the holes in valence band, they release the energy in terms of photon or in the form of light. The process of emitting light in response to the strong electric field or flow of electric current is called electroluminescence. Electroluminescence. A normal PN junction diode allows electric current only in one direction. It allows electric current when forward bias and does not allow electric current when reverse bias. The normal PN junction diode operates only in forward bias condition. Like the normal PN junction diode, LEDs also operates only in forward bias condition. So to create an LED, the N-type material should be connected to the negative terminal of the battery, and P-type material should be connected uh, to the positive terminal of the battery. In other words, the N-type material should be negatively charged and the P-type material should be positively charged. Next, the construction of LED is similar to the normal PN junction diode, except that gallium, phosphorus, and arsenic materials are used for construction instead of silicon or germanium materials. So, in constructing the LEDs, we need to keep in mind that the normal PN junction diode LEDs are similar to the normal PN junction diode, but except that gallium, phosphorus, and arsenic materials are used for construction instead of silicon or germanium. Why? Let's see. In our normal PN junction diode, silicon is most widely used because it is less sensitive to the temperature. Uh, Also, it allows electric current efficiently without any damage. In some cases, germanium is used for constructing diodes. However, silicon or germanium diodes do not emit energy in the form of light. Instead, they emit energy in the form of heat. So, thus, silicon or germanium is not used for constructing LEDs. So, the specific material gallium, phosphorus, or arsenic are not going to uh, emit energy in the form of heat. They are emit energy in the form of light. That's why we use gallium, phosphorus, and arsenic materials instead of silicon or germanium materials. Next, how light emitting diode works. Now see the basic principle or working principle how the light emitting diode works. Light emitting diode works only in forward bias condition. When light emitting diode is forward bias, the free electrons from N side and the holes from the P side are pushed towards the junction. When free electrons reach the junction or depletion region, some of the free electrons recombine with the holes in the positive ions. We know the positive ions have less number of electrons than protons. Therefore, they are ready to accept electrons. Thus, free electrons recombine with holes in the depletion region. In the similar way, holes from p side recombines with electrons in the depletion region. So, this is a pictorial representation of a light emitting diode. When you are just do the forward biasing across the LED, the recombination of holes and electrons takes place, and amount of energy is going to emit out in the form of light. The blue rays which is showing to you is emitted photons or emitted light. Because of the recombination of free electrons and holes in the depletion region, the width of depletion region decreases. As a result, more charge carriers will cross the PN junction. Some of the charge carriers from P side and N side will cross the PN junction before they recombine in the depletion region. For example, some free electrons from N-type semiconductor crosses the PN junction and recombines with the holes in P-type semiconductor. In the similar way, holes from P-type semiconductor across the PN junction and recombines with the free electrons in the N-type semiconductor. Thus, recombination takes place in depletion region as well as in p-type and n-type semiconductor. The free electrons in the conduction band releases energy in the form of light before they recombine with holes in the valence band. In silicon and germanium diode, most of the energy released in the form of heat and emitted light is too small. However, in materials like gallium arsenide and gallium phosphide, the emitted photons have sufficient energy to produce intense visible light. How LED emits light? When external voltage is applied to the valence electrons, they gain sufficient energy and breaks the bonding with the parent atom. The valence electron which breaks the bonding with the parent atom are called free electrons. When the valence electron left the parent atom, they leave an empty space in the valence shell at which valence electron left. This empty space in the valence shell is called hole. So this is the energy band diagram for LED for the light emitting diode. The conduction band, the valence band are shown to you. The recombination process takes place. As the recombination process takes place, and a photon or emitted light is just released in the form of energy. Okay, this is the process of light emission in LED. The energy level of all the valence electrons is almost same. Grouping the range of energy levels of all the valence electron is called valence band. In the similar way, energy level of all the free electrons is almost same. Grouping the range of energy levels of all the free electrons is called conduction band. The energy level of free electrons in the conduction band is high compared to the energy level of the valence electrons or holes in the valence band. Therefore, free electrons in the conduction band need to lose energy in order to recombine with the holes in the valence band. The free electrons in the conduction band and do not stay for long period. After a short period, the free electrons lose energy in the form of light and recombine with the holes in the valence band. Each recombination of charge carrier will emit some light energy. The energy loss of free electrons or intensity of emitted light is dependent on the forbidden gap or energy gap between conduction band and valence band. The semiconductor device with large forbidden gap emits high intensity light, whereas the semiconductor device with small forbidden gap emits low intensity light. In other words, the brightness of the emitted light is depending on the material used for constructing LEDs and forward current flow through the LED. In normal silicon diodes, the energy gap between conduction band and valence band is less. Hence, the electron falls only a short distance. As a result, low energy photons are released. These low energy photons have low frequency, which is invisible to human eyes. In LED, the energy gap between conduction band and valence band is very large. So the free electrons in LEDs have greater energy than the free electrons in silicon diodes. Photons are released. These high energy photons have high frequency. This is the light emitting diode symbol. The symbol of LED is similar to the normal PN junction diode, except that it contains arrow pointing away from the diode, indicating that light is being emitted by the diode. LEDs are available in different colors. The most common colors of LEDs are orange, yellow, green, and red. LED construction. So this is the construction for LED, construction detail, how the LED is going to be construction or manufactured. One of the methods used to construct LED is to deposit three semiconductor layers on substrate. The three semiconductor layers deposit on the substrate are N-type semiconductor, P-type semiconductor, and active region. The active region is present in between the N-type and P-type semiconductor layers. So this is the diagrammatic representation. As you see, P-type in active region and N-type, and the substrate is there on which the all layers are to be put up. Next. When LED is forward biased, free electrons from N-type semiconductor and holes from P-type semiconductors are pushed toward the active region. When free electrons from N side and holes from P side recombine with the opposite charge carriers, free electrons with the holes or holes with free electrons in active region, an invisible or visible light is emitted. In LED, most of the charge carriers recombine at active region. Therefore, most of the light is emitted by the active region. The active region is also called as depletion region. Next, visible LEDs and invisible LEDs. LEDs are mainly classified into two types, visible LEDs and invisible LEDs. Visible LEDs type of LED that emit visible light. These LEDs are mainly used for display or illumination, where LEDs are used individually without photosensors. Invisible LED is a type of LED that emits invisible light, infrared light. These LEDs are mainly used with photosensors such as photodiodes. What determines the color of LED? Very interesting. Which type of material emits which type of color? So, the material used for constructing LED determines its color. In other words, the wavelength or color of the emitted light depends on the forbidden gap or energy gap of the material. Different materials emit different colors of light. Gallium arsenide LED emits red and infrared light. Gallium nitride LEDs emit bright blue light. Yttrium aluminum garnet LEDs emit white light. Gallium phosphide LEDs emit red, yellow, and green light. Aluminum gallium nitride LEDs emit ultraviolet light. Aluminum gallium phosphide LEDs emit green light. So these are the specific materials when they recombine and use in the manufacturing of LEDs emits different colors of light depending upon their choice. Advantage of LEDs: the brightness of light emitted by LED is dependent on the current flowing through the LED. Hence, the brightness of LED can be easily controlled by varying the current. This makes possible to operate LED display under different ambient lighting conditions. Light emitting diodes consume low energy. LEDs are very cheap and readily available. LEDs are light in weight. LEDs are smaller in size. LEDs have longer lifetime. LEDs operates very fast they can be turned on and off in a very less time, that their transient time is very less. LEDs do not contain toxic material like mercury, which is used in fluorescent lamps. LEDs can emit different colors of light. Disadvantages of LEDs: LEDs need more power to operate than normal PN junction diodes. Obviously, they require some more power in comparison to normal diodes. Luminancy efficiency of LED is low. That is, their brightness or their is very low. Applications of LED, the various applications of LEDs are as follows: burglar alarm systems, calculators, picture phones, traffic signals, digital computers, multimeter, microprocessor, digital watches, automotive heat lamps, camera flashes, aviation lighting. So these are the examples or the applications where the LEDs are most commonly used. And nowadays, LEDs are widely used in every aspect. Now, come to the next topic, that is laser diode. Laser diode. As the name laser or laser stand for the acronym light amplification by stimulated emission of radiation. Laser diode plays an important role in our everyday lives. They are very cheap and small. Laser diodes are the smallest of all the unknown lasers. Their size is a fraction of millimeter. Laser diodes are also known as semiconductor laser, junction diode laser, or injection lasers. The laser diode is an optoelectronic device which converts electrical energy. Uh, Basically, laser diode is an optoelectronic device uh, which converts electrical energy into light energy, just similar to the LED, to produce high intensity coherent light. The basic difference between the LED and the laser diode is that they produce high intensity coherent light, whereas normal LEDs cannot produce high intensity coherent light. In a laser diode, the PN junction of the semiconductor diode act as a laser medium or active medium. The working of the laser diode is almost similar to the light emitting diode. The main difference between the LED and laser diode is that LED emits incoherent light, whereas the laser diode emits coherent light. This is the basic difference between the LED and the laser diode. Laser diode construction. Now, the construction detail of a laser diode. The laser diode is made of two doped gallium arsenide layers. One doped gallium arsenide layer will produce an N-type semiconductor, whereas another doped gallium arsenide layer will produce a P-type semiconductor. In laser diodes, selenium, aluminum, and silicon are used as doping agents. For the construction of the laser diodes, gallium arsenide is chosen over silicon. In silicon diodes, the energy is released during recombination. However, this release of energy is not in the form of light. In gallium arsenide diodes, the release of energy in the form of light or photons. Therefore, gallium arsenide is used for the construction of laser diodes. Main steps required for producing coherent beam of light in laser diode. The main steps required for producing a coherent beam of light in laser diodes are light absorption. These are the some steps which are to be, or these are basically the working principle or working cycle of a laser: light absorption, then spontaneous emission and stimulated emission, mm, absorption of energy. Now, the absorption of energy is the process of absorbing energy from the external energy sources. In laser diodes, electrical energy or DC voltage is used as the external energy source. When the DC voltage or electrical energy supplies enough energy to the valence electrons or valence band electrons, they break bonding with the parent atom and jumps into the higher energy level, conduction band. The electrons in the conduction band are known as free electrons. This is the pictorial representation of absorption, uh, spontaneous emission, and stimulated emission. Now, we are just going to discuss each diagram in a detail. First, we had discussed this absorption in a previous slide. In the valence electron absorb the energy, electrical energy, and just gain the energy and reach to the E2 level. Valence electron jump into higher energy state after absorbing the energy. Now, spontaneous emission. Uh, as the free electron cannot be make himself stable at E2, it certainly tries to get on the E1 level, and as he returned to the E1 level, it releases an energy, free electron releasing photon or light energy while recombining with the hole. So this is for the single electron hole pair. Now stimulated means more number of uh, electrons get recombined and a coherent beam of light is produced, and that coherent beam of light is more intense and unidirectional, and this is the phenomena for laser construction or working principle of laser. Now spontaneous emission, now discuss the spontaneous emission. Spontaneous emission is the process of emitting light or photons naturally while electrons falling to the lower energy state. In laser diode, the valence band electrons or valence electrons are in the lower energy state. Therefore, the holes generated after the valence electrons left are also in the lower energy state. On the other hand, the conduction band electrons or free electrons are in the higher energy state. In simple words, the free electrons have more energy than holes. The free electrons in the conduction band needs to lose their extra energy in order to recombine with the holes in the valence band. The free electrons in the conduction band will not stay for long period. After a short period, the free electrons are recombined uh, with the lower energy holes by releasing energy in the form of photons. Now, stimulated emission is the process by which excited electrons or free electrons are stimulated to fall into lower energy state by releasing energy in the form of light. The stimulated emission is an artificial process. In stimulated emission, the excited electrons or free electrons need not wait for the completion of their lifetime. Before the completion of their lifetime, the incident or external photons will force the free electrons to recombine with the holes. In stimulated emission, each incident photon will generate two photons. All the photons generated due to the stimulated emission will travel in the same direction. As a result, a narrow beam of high intensity laser light is produced. Next, how laser diode works. When DC voltage is applied across the laser diode, the free electrons move across the junction region from the N-type material to the P-type material. In this process, some electrons will directly interact with the valence electrons and excites them to the higher energy level, whereas some other electrons will recombine with the holes in the p-type semiconductor and releases energy in the form of light. This process of emission is called spontaneous emission. Next, this is the pictorial representation or diagrammatically representation of a laser diode. As you see, when the p-type or n-type semiconductor of different constructing material other than the normal p-n junction diode uh, and uh, applied to the potential positive terminal with p-type, that is the forward biasing, and the light absorbed by the or the light electricity absorbed by the free electrons, and as we had seen in the energy band diagram, they just get the energy from the external source and reach to the next level, and they can't stable for a very longer period over there and just try to recombine with the holes and reaches to the lower energy level. And when they are just recombined with the holes, they release a photon or a light in the form of photon energy, and this photon in a coherent mode reflects the light in a stimulated sense, and the resultant light is known as the laser light. The photons generated due to the spontaneous emission will travel through the junction region and stimulated the excited electrons, free electrons. As a result, more photons are released. This process of light or photons emission is called stimulated emission. The light generated due to stimulated emission will move parallel to the junction. The two ends of the laser diode structure are optically reflective. One end is fully reflective, whereas another end is partially reflective. The fully reflective end will reflect the light completely, whereas the partially reflective end will reflect most of the part of the light but allows a small amount of light. The light generated in the p-n junction will bounce back and forth hundreds of times between the two reflective surfaces. As a result, an enormous optical gain is achieved. The light generated due to the stimulated emission is escaped through the partially reflective end of the laser diode to produce a narrow beam laser light. All the photons generated due to the stimulated emission will travel in the same direction. Therefore, the light will travel to the long distance without spreading in the space. So this is very important. All the photons are generated due to the stimulated emission will travel in the same direction. Therefore, this light will travel to a long distance without spreading. That's why it is called monochromatic source of light. Now, these are the advantages of laser diode. Uh, Laser diode is simple in construction, light in weight, very cheap, and small in size, and highly reliable compared to other types of lasers. Longer operating life, high efficiency, mirrors are not required in the semiconductor laser, low power consumption. Disadvantages of laser diodes: not suitable for the application where high powers are required. Semiconductor lasers are highly dependent on temperature. Next, application of laser diode. Laser diodes are used in laser pointers. Laser diodes are used in fiber optic communication. Laser diodes are used in barcode readers. Laser diodes are used in laser printing. Laser diodes are used in laser scanning. Laser diodes are used in range finders in the military applications. Laser diodes are used in laser absorption spectrometry, that is in the medical field. There is a vast use of laser diodes. Now come to the next topic, that is tunnel diode. Tunnel diode. As by the name, we come across to some conclusion. The sort of tunnel or tunneling effect is there. That's why uh, its name is called to be tunnel diode, because the specific construction or spatial construction of a diode result in some sort of tunneling effect in VI characteristic. So due to that, its name is tunnel diode, and it's used somewhere in a very specific applications also. A tunnel diode is heavily doped p-n junction diode. First of all, a tunnel diode is heavily doped p-n junction diode in which electric current decreases as the voltage increases. So as you increases the voltage go on increasing, the current will go on decreasing. In tunnel diode, electric current is caused by tunneling. The tunnel diode is used as a very fast switching device in computers. Mm. It is also used in high frequency oscillators and amplifiers. This is the symbol for tunnel diode. The circuit symbol for tunnel diode is shown in the below figure. In tunnel diode, the p-type semiconductor acts as an anode and the n-type semiconductor acts as a cathode. Uh, in Zener diode, the symbol is almost somewhat, but having some change in the edges of the vertical line. And this is the symbolic representation of a tunnel diode. What is tunnel diode? Now, what actually the tunnel diode is? So, tunnel diodes are one of the most significant solid-state electronic device which have made their appearance in the last decade. Tunnel diode was invented in 1958 by Leo Isaki. Leo Isaki observed that if a semiconductor diode is heavily doped with impurities, it will exhibit negative resistance. Negative resistance means the current across the tunnel diode decreases uh, uh, when the voltage increases. So, it exhibits negative resistance basically. So, the first point is noted to be the negative resistance. Uh, in 1973, Leo Isaki received the Nobel Prize in Physics for discovering the electron tunneling effect used in these diodes. A tunnel diode is also known as Isaki diode. A tunnel diode is also known as Isaki diode, which is named after Leo Isaki for his work on tunneling effect. The operation of tunnel diode depends on quantum mechanics principle known as tunneling. In electronics, tunneling means a direct flow of electrons across the small depletion region from n-side conduction band into the p-side valence band. Concept of tunneling. The depletion region or depletion layer in p-n junction diode is made up of positive ions and negative ions. Because of these positive and negative ions, there exists a built-in potential or electric field in the depletion region. This electric field in the depletion region exerts electric force in a direction opposite to that of the external electric field. Another thing we need to remember is that the valence band and conduction band energy levels in the n-type semiconductor are slightly lower than valence band and conduction band energy levels in the p-type semiconductor. This difference in energy levels is due to the difference in the energy levels of the dopant atoms, donor or acceptor atoms. used to form the N-type and P-type semiconductor. Electric current internal diode. Internal diode, the valence band and the conduction band energy levels in the N-type semiconductor are lower than the valence band and the conduction band energy levels in the P-type semiconductor. Unlike the ordinary PN junction diode, the difference in energy levels is very high in internal diode. Because of this high difference in energy levels, the conduction band of the N-type material overlaps with the valence band of the P-type material. Quantum mechanics says that uh, the electron will directly penetrate through the depletion layer or barrier. If the depletion width is very small, the depletion layer of a tunnel diode is very small. It is in nanometers, so that electrons can directly tunnel across the small depletion region from N-side conduction band into the P-side valence band. In ordinary diodes, current is produced when the applied voltage is greater than the built-in voltage and the depletion region. But in tunnel diodes, a small voltage which is less than the built-in voltage of the depletion region is enough to produce electric current. In tunnel diodes, the electrons needs not overcome the opposing force from the depletion layer to produce electric current. The electrons can directly tunnel from the conduction band of N region into the valence band of P region. Thus, electric current is produced in tunnel diode. How tunnel diode works? Unbiased tunnel diode, small voltage applied to the tunnel diode, applied voltage is slightly increased, applied voltage is further increased, applied voltage is largely increased. So these are the some steps, and due to the effect of these steps, a tunneling effect is occur. So unbiased tunnel diode, when there is no biasing, no tunnel current. A small tunnel current, that small tunnel current is showing to you. When you just start increasing the voltage, the current is going to increase, and as you increase the voltage, current reaches to the maximum tunnel effect or the maximum level. And when you start further increasing the voltage, the current started decreasing. And as you see the red color, the tunnel current starts decreasing. And this diagram shows the zero tunnel current, maximum forward current. So when you continuously increasing the voltage, again the current start increasing rapidly and maximum forward current is going to be flow out. Advantages of tunnel diode: long life, high speed operation, low noise, low power consumption. Disadvantage of tunnel diodes cannot be fabricated in large numbers. Being a two-terminal device, the input and output are not isolated from one another. Application of tunnel diodes. Tunnel diodes are used as logic memory storage devices. Tunnel diodes are used in relaxation oscillator circuits. Tunnel diode is used as an ultra high speed switch. Tunnel diodes are used in FM receivers. So this is all about the tunnel diode and the phenomena of and now in the next lecture we are going to start with the Schottky diode. So this is all about the diode, tunnel diode, and the LEDs. We had covered the light emitting diode, the laser diode, and the tunnel diode in this lecture. In next lecture, I'm going to start with Schottky diode. So thank you all. Have a nice day.